So this is improved performance and stability on your iOS apps. I'm a iOS developer and consultant here in the Twin Cities. I've been doing Cocoa development for a long time, since the early days of macOS 10. And for the past couple of years, I've been doing iOS development. And a lot of that I've spent doing some performance analysis. So I thought I'd show some of the tricks I've learned using instruments and how to make your code faster. Just to get an idea how much time is spent on instruments itself, how many people here have used instruments before? Okay, so I should still probably go over instruments. Okay, so I put together an example for this talk. Once this comes up here. And this is basically what I'll be building. Is this photo view here. It has these thumbnails. And then you can scroll, and as you can see, it scrolls pretty smoothly. And I chose this example because scrolling is actually something that can be pretty hard to do efficiently. And users can pretty easily perceive lag when you don't have scrolling right, when you have less than 60 frames per second, which of course is what you want to shoot for. So, of course, this is the final version, though. This is what we end up with, and you'll see there's quite a lot going on behind the scenes, actually, to get to this point. So what I'll be doing also is I'm going to be bouncing back and forth here between my computer and iPad, so you have to bear with me on that. So let me show you actually the first version I started with. And one thing to note, too, is that this project I did with Art, and for those that don't know, it's automated reference counting, which gets rid of the manual memory management you used to have to do before. And I highly, highly recommend you use that for all your projects. Even for somebody that's really experienced working with Objective-C, Art just is going to do a better job than you will. You'll slip up and make mistakes, forget to retain something, and then before you know it, a low memory situation happens. You expect an object to be there, it's not, crashed. So just let the compiler strip those retain and releases for you, which is what Arc does. And just let Arc worry about it. You'll see a huge improvement in the stability of your apps. So I went ahead and used Arc here for my example. So I've got a view controller here that I'm loading the photos into. It just loads here. And I've actually got a directory on disk of full-size photos. And so what has to happen is we have to access those photos, load them in, scale them down, and then present them to the user. So I've got this scroll view here that I'm going to load those photos into. And then I've got here a view controller. And the first thing it does is, when it launches, it calls layout photo. And it just really iterates through and requests a photo, creates an image view, and plots that in a grid, plots those photos across the screen. One thing you'll notice here is I'm iterating through all the photos. So at launch, I'm going through all the photos, scaling them all, adding them to the subview. And I've got this model object here that's pretty simple. You can create an instance of it, ask for the number of photos, grab a photo, and it returns actually the full-size photo and lets the UI image view do the scaling down. And it's usually a good idea to start with something simple like this, because a lot of times the built-in APIs will be a lot faster than you expect them to be. For example, the UI image view might do something really smart with scaling photos, and so to do anything else would be premature optimization. So I started really simple, and let's run this here and take a look at how it does. So I'm going to run this here in the simulator. The first thing you'll notice, of course, is it takes a really long time to start up. And that's because we're loading all the photos. And a good thing to keep in mind is that the performance difference between the simulator and the actual device can be huge. It can be 10 to 20 times difference. So if it's going to be slow here in the simulator, it's going to be really slow on the device. Another thing to keep in mind is on an actual iOS device, if your app doesn't start up in a certain amount of time, it will crash. There's this thing called the watchdog process, and it keeps track. I think it's 5 seconds. If your app doesn't launch within 5 seconds, it'll just kill you right then and there. And the thing to be careful of is even when you're running on the device, and it looks like it launched, everything's fine. If you have it connected to Xcode, and you have the logger and it's spitting out output, it actually disables the watchdog. Because a lot of times starting up with the debugger can take a lot longer than 5 seconds, and getting Xcode initialized. So for those situations, it disables the watchdog. So you got to be really careful that you also run your app without Xcode, just on the device, to make sure it starts up as efficiently as within that window.
Question on that.
Yeah.
Can you define what exactly does it mean to launch on the device? Like, what point are you officially launched?
Basically, anything in. I'll show you here. So that's a really good question. Anything in the app delegate here, like application did finish launching, this here, and then there's the a lot of initialization example. For example, I don't think I have one in here, but if you had a constructor for your view controller, you have to be careful doing something really expensive in there because that'll block the app from launching. It's best to get a UI up, let some views load, and schedule that work for later. So you let the application did finish launching with options here. Do the basic setup you can, and then have another method and say, hey, do this after delay, do this after like a quarter of a second. And that'll give it so that the system will see, hey, my app is up, and then you can start initialization of more complex things if you have to load large images or anything like that.
You actually have a method to finish launching with options. At that point, just basically you're saying delay wherever you can.
Yeah, absolutely. So it'll look really fast, because what's happening is when this method's running, the operating system's actually just displaying a static image to the user. So they're just seeing that splash screen. And then once it's actually loaded, it'll take away the splash screen, and then you can do your initialization.
Thank you.
Yeah. Another thing is, make sure that you're testing on the device frequently, because there's such a difference between the simulator and the device. I've seen projects and I've seen situations where you don't test towards the end of the project. A developer maybe doesn't have a device and they're doing most of the development on the simulator. That's just a recipe for disaster. You want to be testing on the device frequently. And not only that, you want to make sure that you're using the oldest device that you intend on supporting, because there can be a huge difference between an iPad 1 and an iPad 2. I've seen it where the developer has an iPad 2, they develop an app for the iPad, works great on an iPad 2. Towards the end of the project, I guess I better see how it runs on the iPad 1. And it's just terrible. So the best thing you can do is, if you need to support the iPad 1, do most of your development with an iPad 1. So then you know it's going to just scream on an iPad 2. So we can see here now it's up and running, and scrolling's pretty nice. It's working pretty well. But launching took a long time. That's one problem. And another thing is we really need to take a look here and see how we're doing in terms of memory. I want to run that simulator. So I'm going to use instruments, and you can run that here right from Xcode. Instruments is Apple's performance tool, and there's a bunch of different tools here I'll talk about, but right now we're going to start with allocations. So allocations is we're going to launch our app, and it's going to give us an idea of our memory use. And basically we have a timeline here showing our memory use over time. And we've got multiple tools here, or instruments, I guess I should say, we can switch between. Then we've got this summary here showing us our memory overall. And it looks like we're not doing too bad, 17 megabytes. That's pretty good. And you'll notice too that when I go over, I can take a look here, and it'll show me actually, so it's showing me all my mallocs as 16 bytes. And I can even go a step further. I can expand this side view, and it can show me where in the stack that was allocated. So I can do that for, I don't know, let's take a look at this CF dictionary. Now, most of this is system stuff that UIKit's doing. But you can use this as an idea to get an overview of what's happening in your app. You'll see your classes here. If you have a lot of a certain class, and you can see where you're allocating it, what percentage of the memory is being used. So, however, you don't want to rely just on allocations, because allocations will lie to you. It actually is in this case. It says 17 megabytes here, but it's actually not that accurate. What we really want to be using for this is VM Tracker. So let's turn that on. And you'll see right away that dirty memory, that's really the amount of memory being used by your app. And that's what you want to pay attention to. That's going to be your most accurate representation of memory used on the device. You see here it's actually pretty horrific. It's 618 megabytes. There's no way this is going to run on an iPad 2. I mean, they have 512 megabytes. It's not going to work. And you'll see this, most of this is taken up here by memory tag 70. That's actually image data. I don't know why they don't label it as image data, but for whatever reason it's labeled as memory tag 70. For some reason, allocations doesn't show, like for a UI image, it doesn't show in allocations that data associated with the UI image. It only shows up here in VM Tracker. So make sure to keep an eye on that, especially if you've got a multimedia app where you're going to be processing lots of images and things like that. Watch out. Another thing is if you have a lot of views, the backing for your views isn't going to show up in allocations. It's going to show up here in VM Tracker. So when you want to get an idea of how much memory your app's using, come here in the VM Tracker and take a look at the dirty memory. So clearly this first approach is totally not going to work. So we got to do something a little smarter. So I've got another version here. Let me pull that up. Version 2 of the app. That's a little bit smarter. So I've done a couple things here. One is I really only load images on demand. So I've got this loop here. It's kind of hard to see. I've got this loop. And right here, for each image, I check. I calculate where the image is going to be, where that photo thumbnail is going to be. And then I calculate where we are, where the scroll view is, where our bounds is of the scroll view. And see currently if that photo's on screen. If that photo's not on screen, there's no reason for me even to calculate a thumbnail. So I don't do it. So as you scroll, photos are added and going to be removed, which allows us to do a lot less work. Other thing I did to also help improve memory, and that first thing's also going to help improve the startup, was I've got this little bit of code here. This is my model object, the photo data source. I've got photo at index here. So I changed it a little bit. I'm doing UI graphics, begin image context, and doing some drawing. And so I'm reading in the full-size image, and then I'm scaling that image down. And I'm keeping around the scaled image. And the scaled image is going to be drastically smaller than the original full-size image. So we're going to use a lot less memory. So let's go ahead and run that and see how we're doing.
So that you're doing that different. What you were doing before was just scaling the UI image view.
I was just putting it in the UI image view,
okay.
And then saying, hey, the view is 300 by 200, and then hoping that the UI image view would just like take care of that for me. But it doesn't. It keeps the full image data around. So I'm going to scale it ahead of time before I pass it off. So we can see here now how we're doing with memory. Let's turn on VM Tracker again. Okay, so now we're doing a lot better. 55 megs. That's actually reasonable. That's something that could run on the device. Another thing we should take is if we there's another tool I want to use here, because if you take a look at the app and I run it, let me put this here. You'll see when I scroll, it's getting laggy, it's stuttering along. And now it's probably pretty easy to figure out here that it's the scaling of the images that's causing the problem. But just to show you how like the basic problem here, how you use instruments, let me show you another tool. And that's the time profile. So let's launch that. So I'm running the time profile here, and here it's showing us kind of how much work the CPU is doing. It's going to track that over time. And what I'm going to do is scroll a bit here. And then let's stop. Take a look what's going on here. So once again, we've got our timeline, and now we've got this this outline view down here. And I can expand this, and it's showing me where most of the time is being spent on the CPU. So I can see here 100% here is on the main thread, so that's not good because it's potentially blocking the UI from scrolling smoothly. I go down here more, where we have to dig through a bunch of system layers before we'll actually, here we go, now we're getting the scroll view. And now, here we are at our code. So 68% of the time is spent here in photo data source. And we know that's what's blocking the UI now. Another thing you can do here in Instruments is I can double click on this. It's actually going to take me to that bit of code, and it's going to highlight that code and show me, of the time spent in that method, what are the hotspots. So we can see here this draw and rect is really, really slow, taking 96% of the time. So, what can we do about that? Well, one thing we can do is we can move the scaling of the image to a background thread. So that way it doesn't interfere with the UI at all. The UI can scroll smoothly, independently of the image scaling. So we can go ahead and do that. However, we can't take the code, this code right here, as it is right now. And the reason is because we're using UIKit, and UIKit is not thread safe. And this is actually a huge source of crashers, is accidentally using UIKit on a background thread. Adding subviews, doing drawing here with this UI graphics, can't do any of that. And the nasty thing is, it won't be obvious at first that you're doing that on a background thread. A lot of times it will continue working for a while, and then just randomly crash. Or I've also seen it where it works, but you'll get random memory leaks, and over time, memory builds up, and then your app crashes. And going in and removing the UIKit work on the background, also new. It works again. Yeah?
Is there any way to pull some kind of trickery to make sure you're not using any shared resource like begin image context?
Yeah, that's
kind of global thing. Can you use UIKit if you're very careful that all of your objects that you're working with have never been touched by the main thread? And there's nothing
the only thing is I've seen. Yeah, even the only thing officially I've seen is UI view. But here's the weird thing. If I look at the docs here, where does it say it? Manipulations must occur on the main thread. The only time this may not be strictly necessary is when creating the view object. So that's the only time. But it says may not be strictly necessary. So that's kind of like weaselly right there too. So I don't know what that means. So I do nothing on the background thread having to do with UIKit, just to be sure.
If you have some secret mojo.
No, one thing I have, and maybe if I have time I get into it at the end. I wanted to include it, but I ran out of time. Is there's a way you can put a little bit of code in there when you're debugging to try to detect if you're doing UIKit stuff on the background and just crash your app right then and there. So you don't get that weird, subtly broken behavior. It's just like a hard crash. Or I can show you some of that after the talk as well. So yeah, we got to be really careful here. I mean, pretty much the two biggest sources of crashers working on, from my experience, is improper memory management and it's UIKit stuff on the background thread. There is a solution though. We can use core graphics, which is a bit lower level of an API, but it is thread safe. And it'll require a bit more code. And what we need to do is we basically create a bitmap context in the background. We do our drawing into it and pass that image on to the main thread. So let me show you a bit of that. So I'm going to use something to NS operations queue. So once again, I'm in my photo data source again. And I changed my API a little bit though. Now the UI is going to request the photo, and then at a later time there's going to be a delegate. It's going to call its delegate back with the image. So here's the the method the delegate has to implement, and it'll get called back and be handed out that image. So what I've done then here in this code is I create this operation queue. And it's a great way in UIKit or in iOS in general to create background processes and get work done in the background. Because then what I can do is when the UI requests a photo, I can schedule a bit of work, and I can use a block here to put my work that I want to do. And then once that work's done, I can use NS operation queues to perform this on the main thread. And then further down here is this core graphics code. I'm not going to get into it too much here because it pretty much does what that other code did before. It just scales the image down. But because it's lower level, it requires a little more code. So let's try that. Well, actually, I'm going to skip over trying this just for the sake of time. But I did run this, and it doesn't actually work that great. The reason is because as you're scrolling, more and more worker processes are being created in the background. So what you really want to do is you want to cancel stuff. So like if I start at the beginning and I'm working on scaling some images, but then I scroll way down, there's no need to still be working on those images up top. So I added a way to cancel some of that work, but stuff was still kind of weird. It was very laggy. You'd scroll down, it would take a long time for images to come in. And it's kind of tricky at first to figure out what's going on, but you can use instruments again to figure that out. Let me show you here. So this is a trace I did earlier, and you can see it's working like nuts here. But digging in here, it looks mostly normal. It's just scaling UI stuff, or scaling images as you'd expect. But if you change the view here, there's a couple views over here as instruments. This will show you work done for CPU. This is the default view. And then there's another view here that's going to show you per thread. And if we look here, right away you'll notice there are a ton of threads. So this is actually what's causing the latency in the UI, is as we're scrolling down, it's creating tons of threads. And once a thread starts, you can't cancel it. So NS operation queue, what it does is when you schedule work, it checks to see if there's a thread available that it can use that's recently completed work. If there's nothing available, it just goes ahead and creates a new thread. And so when we're scrolling really quick, it just keeps creating new threads, up to the limit, which is, I believe, 64 threads. And so 64 threads, all scaling images, the UI is going to be just terribly slow. So what I had to do was I had to go in, and there's a way with NS operation queue to clamp down the number of concurrent operations. So it's a pretty simple API. You can just say, hey, max concurrent operation count 2. So no more than 2 images will be scaled at once. So that keeps the UI pretty responsive. And actually, let me show you what that looks like here on the device. Okay. So version 4 here is what we're going to look at. And so we've gone a significant way already that this can run on the device. And now as I scroll, it's coming in pretty fast. It's working pretty well. And you can see them filling in here. So okay, so that looks pretty good. Can we do even better? Well, we can. There's a number of options available. And one thing to think about when you're doing this kind of performance analysis is, and it might seem really obvious, but it's good to step back and think about it, is there's really just 2 ways we can speed up our app. We can either find a way to do less work, so in this case, scale less photos, which we've done, so we're only scaling the photos that are currently on screen. And then the second thing is doing the same amount of work, but have to find a way to do it faster. So that's something we can look at now, is there a way to scale these photos down faster? And what I did a trace again Oh yeah, thank you. Oh, and another thing I should mention too to think about when you're looking at these instruments traces is even if you see something that's you're like, oh, that's kind of stupid, I can fix that, but it's only, I don't know, 1% of the time spent there. I mean, realize that even if you can get that bit of code down so it executes in 0 seconds, which you can't, it's impossible, your app's only going to be 1% faster. So really, hit the big areas first. You know, hit the 60%. You know, don't even worry about the small stuff. And so that's what we'll be looking at here. Is I scaled it or I profiled it again, and this time you can see the main thread is 0.8% of the time, so it's free to do UI stuff. We're spending 77% of the time here in a background track. And if we take a look here, going down, we can see that a lot of the time spent drawing the image, doing read and resample. Okay, so that sounds like scaling stuff to me. So what are our options for making the scaling faster? Well, there's a couple things. One is core graphics and what we're using to do scaling. A lot of times is a slow part of the software stack in iOS. And the reason being is that core graphics is run on the CPU. And things that are really snappy, like the animations, are done by the GPU using core animation. So, you know, can we use the GPU some? Well, Apple has something called core image that we can try, which uses the GPU to do image operations. There's also another thing called the Accelerate framework, which uses the something on ARM called Neon, which is equivalent to SSE on Intel. It's basically a vector unit for doing multimedia computations. So you can, it's single instruction, multiple data, and it's a way to parallelize things on the CPU. So we can check that out. And Accelerate actually has a lot of options. It's got things like image processing, linear algebra, digital signal processing, and a lot of just general stuff as well, math functions, trig, that sort of stuff. So we can try that. And then there's another thing, an API Apple added for creating thumbnails. We should probably try that. That was added, I believe, as of iOS 5. And so I went through and I used, I made a modified version of the app. Let me bring that up here. That I modified so that you can, actually I have one open already, that times these different operations, and it just goes through and just crunches a lot of images. And I just put a simple log statement in there. I just say n is time interval time, and I record the time it started, and they can just print out, you know, the time it ended minus that. And so I get this dump of timings. And I ran this on a lot of images, and I graphed it so you can see how it's doing. So CG context, well, the operations, the different types are on the bottom. Seconds is on the left, so shorter is better. And CG context there, the first item, is what we started with. That's core graphics. I've got the Accelerate framework, which actually performed worse, which was surprising. The interesting thing, though, is running this on a Mac versus an ARM device like iPad or iPhone. Accelerate did awesome on the Mac. It was far and away the fastest. But on iOS devices, the slowest, as you can see. I'll get to CG context v2 in a second. Create Thumb is Apple's API. We can see here it's a little bit slower than just plain core graphics. So it's probably just using the core graphics methods internally. And then core image here. Core image actually didn't do that well, which was weird. I expected it to do a lot better because I figured most of the time is spent scaling the image. What's going on here? Well, I used instruments again to profile all these. And it looked like with core image that most of the time is actually spent reading the data from the disk, not actually scaling as the initial trace led me to believe. I thought the resample, I thought all of that was resampling the image to scale it. No, that was actually reading the image format from disk. So to confirm my hypothesis, I I created a version that reads the data separately and then scales it in memory. And sure enough, it was about the same time, but in fact it was a little bit faster, and that's CG Context V2, which I just stumbled on accidentally. But it seems that reading the data all at once gave a I/O performance boost. And so that's the method that we'll actually go with, is that center one right there. And so we just ended up using core graphics, because it's not, the other methods aren't substantially faster because of the I/O. But there's, one thing I want to mention with doing benchmarks like this is you got to be careful that your benchmarks aren't misleading. You have to at least collect a bunch of samples. You can't just scale one image with core image, scale another image with core graphics, and say, oh, okay, it looks like one's faster. No, you got to run this on a lot of images. And you need to calculate an average, calculate a variance, give you an idea, work with the data, bring that into Excel. And ideally what you should do is use a statistical method to make sure that it's significantly statistical, or statistically significant. That basically what you're testing, and there's one test you can use that's good for something like this called the unpaired t-test. And what you're using it to do is say, is one of these versions actually faster than the other, or is it just by chance, just by random fluctuations, that one of these turned out to be faster than the other? And the t-test can help you make that decision with your benchmark data. And there's a lot of tools that can do it. Excel can do it. Open source software R can do it. So anyway, something to keep in mind when you're doing these kind of benchmarks.
Before you move on, can you talk about how long it took you to do that?
It actually didn't take too long. The hardest part was, I'd say it took a couple hours. The hardest part was just figuring out the APIs, because like the Accelerate framework I'd never used. So I wasn't really sure how to use it. Most of it was pretty straightforward, and I could use the same like application shell and then just get the data and crunch it and take a look. So yeah, it wasn't too bad. But it was totally different than I expected. I really thought that scaling the images was the slow part, and that core image was going to stop it. So it turns out that doing this doesn't help that much. We didn't make a massive improvement here. So now that we know I/O is the problem, we need to do something about that. So I've got another version of the app here where I did some caching. So what we'll do is we'll scale down the images, and then we'll keep a version of that image in memory. So we scale up, the user scrolls by that area again, we've got a cache. We can just grab it right from memory. No disk I/O required. What I'm using to do that is NSCache. And I recommend NSCache for this. It's pretty awesome because it's fast, it's thread safe, and you don't have to worry about running out of memory because it responds to low memory runs. So you start running out of memory, it'll automatically purge objects.
Does it purge old first?
Yeah, it's the version of it's some variant of the least recently used.
Cool.
And the other thing, in this case, you can set a limit. I actually set a limit. You don't have to, because you can say, just whenever the app gets a memory warning, clear it out. So this is really useful for this kind of stuff. But okay, so what if those images aren't in memory yet? Well, we can improve on this a little more by having a file system cache as well. So what we do is we scale the, when we need an image, we first check the in-memory cache. Okay, if it's not there, then we check the file cache in the caches directory for your app. And then if we can't find it there, then of course we compute it and then save it back on the file system and the in-memory cache. And because we're saving the scale version, there's way less image decoding to do, and there's way less I/O to do. So that actually gives us a pretty good performance boost. And let me show you that version right here. Come on, iPad. Okay, so this is version 5. Okay, looks all right, but I don't know if you can tell on the screen there, but it's kind of stuttering a little bit. as we scroll by, which is pretty weird. You wouldn't expect that to happen. And once again, we can pull out instruments, figure out what the heck is going on here.
If you scroll down right now that it's going through cache, it won't start.
It won't start now. And here's the thing, is this other stuff up top here is on the file system cache, and it's stuttering. But the stuff that's in memory won't. The reason being is once you look at the trace here, is we've got, oh yeah, thank you. Good to do that. Is, we can see that there's a bunch of work being done on the main thread, which is totally not what we'd expect. I thought we moved that work to the background thread. So, okay. If we go down here, we can see here's our main thread, 82% of the time. All right. That's weird. What's going on? Well, we can work our way down here through the system stuff. We get the scroll view. Sorry, CA transaction flush. And we can go in here. So this is core animation. What the heck is core animation doing? Keep digging down and see if anything makes sense. Now we've got PNG here. Well, the stuff we're caching on disk, we're saving in the PNG format. And what's happening is we're reading in that cached PNG on disk, then we're putting in a UI image view. But it's not waiting to decode that PNG until it's ready to display it. And that's happening on the UI thread. So the stutter is caused by the system being slowed down, having to decode PNGs. And this is something I've seen actually happen in other apps too. Just any kind of app that has a timeline or a table view that has lots of images in it. You can see it slow down. A lot of times that's caused by image decoding. So there's a way we can fix this though. And what we do is we force it to draw again in the background. So we read in that UI image. Let's see, I've got the version here. We read in that UI image. We send it through that same draw procedure as if it's being scaled, but in this case it doesn't have to be scaled because it's the proper size already. Go down here. Here we can see this is where I'm writing it out. And here is where I'm checking to see if the file exists. And if it does exist, I'm sending it through the scale image method again. And that's causing core image to draw the image, and it's causing it to decode the background, decode the image in the background. And so then we switch over to my iPad again. We can see what it looks like decoding the image in the background. Which this is actually the first version I showed you. This is the, so we can see here, we're reading caches from the disks pretty fast, but it's also smoothly scrolling. So, yeah, and so, one final improvement you can make here that I didn't do is put some placeholder views in here. I didn't get a chance to do that, but you could have a placeholder, just a generic icon for an image to sit there until it's loaded from the background to make it appear even faster. So, in summary, try something simple first and profile it, and try to do less work first, and then once that doesn't work, try better algorithms, better data structures. But first, check to see if there's a way you can delay that work. Maybe only process images like we're doing here for that area of the screen. And for crashes, prevent crashes, make sure you're using ARC. Can't recommend ARC enough. And don't do UIKit stuff in the background. That's a great way to get random crashes and memory leaks. And finally, make sure you're always testing on the slowest device you intend on supporting. And so that's all I have, and I'll be putting some of this up on my website and also on the wiki. And here's my contact information. Anybody have any questions?
Did you try it on iPad 1? try this app?
I actually didn't. The reason I didn't is I should try it and see how it does. Is because you can't do the display stuff. I can't show the display of the iPad 1, so I expect the iPad 2. But yeah, thanks.
Actually, if we've got time, can you show that way that you have for the background
Yeah.
UI kit?
Well, actually, you know what? If you have time, there's one more thing. One more tool that's just really, really cool. So there's something, a newer tool called System Trace that instruments can do. And you can get a crazy level of detail what's happening in your app once this loads up here. This could help you too determine if it's on the background. So here it looks, you know, it's not very interesting. Okay, whatever this is. Well, I can switch over to this view here that shows threads, and it shows all kinds of stuff, like system calls, and I can click on this. It'll show you what system call it did. It'll show you. Let's see if there's a. I can't stop at that arrow. But it'll show you arrows. I can't stop there. Oh, there we go. These arrows are actually context switches between threads. So you can see where it's context switching, what's causing context switches, all sorts of good detail here. And you can click on any of these points and it will show you what's executing there. So you can click around and say, okay, you know, oh, I'm doing something UI view background in this background thread. That's not good at all. The other method is actually I don't have let's see. Is using trying to remember the name of it. It's you only really want to do this for development, but you swap methods at runtime. You say, hey, add subview, for example. It's something you definitely don't want to be doing in a background thread. So what you do is you swap out add subview and put in your own implementation. The first thing your implementation does is it checks NSThread. And there's a way here to get the current thread. Oh, here we go. Is main thread. So the first thing you do is you check, hey, am I in the main thread? If I'm not, then crash. And let me see. Yeah, I can't remember the name of it right now, but there's a way that you swap runtime. You swap method implementations at runtime.
Just by loading in the category or something?
No, it's not by category. There's like a little bit. Swizzle, thank you, that's it. You swizzle the methods. And so you say, okay, let me swap it out. Do the is main thread test, and then you call the original implementation. So anytime you're adding a subview, you first check to make sure that. I don't have anything prepared for that, but it's do it for methods swizzle. There's some.
There's a class on GitHub that will go over it.
Yeah, that's that you know you can provide it to two implementations. And, that's actually what I think I used before when I did this. So that plus is main thread, and you'll be able to get something together. Any other questions?